Hey everyone, and welcome back to the channel. If you are new here, make sure to hit the subscribe button and click the bell icon so you don't miss out any of my coming videos. Today we're diving into fascinating world of neural networks. Now I know neural networks might sound like something reserved for tech geniuses in lab coats, but hang tight, because by the end of this video you're going to know exactly what they are, how they work, and why they are the brain behind so much of today's cutting-edge technology. Ready to unlock the mystery? Let's jump right in. Let's start with the basics. Neural networks are a type of machine learning model inspired by the human brain. Just like your brain is made up of billions of interconnected neurons that process information, a neural network is made up of artificial neurons, also called nodes or units, that are connected together to process data. But instead of neurons firing off electrical impulses, these artificial neurons pass along numbers. And when I say numbers, I'm talking about data. The information that these networks are trained on to recognize patterns, make predictions, and even learn from experience. So how does a neural network actually work? Imagine you are trying to teach a child to recognize a cat. You'd show them a lot of pictures of cats, pointing out the ears, the whiskers, and the tail. Over time, the child learns to identify a cat on their own. A neural network works in a similar way. It's trained on a data set, let's say thousands of labeled images of cats and dogs. The network then learns to identify patterns that distinguish a cat from a dog. Once it's trained, you can show it a new image and it will be able to tell you whether it's looking at a cat or a dog. Now let's break it down a bit more. A neural network is typically organized into layers: an input layer, hidden layers, and an output layer. The input layer is where data enters the network. This could be anything from an image to text to sound. The hidden layers are where the magic happens. This is where the network processes the data, looking for patterns and making sense of it. Each neuron in a hidden layer takes the output of the neurons in the previous layer, applies some kind of transformation, and then passes it on to the next layer. The more hidden layers a network has, the more complex the patterns it can learn. This is what we call a deep neural network. And yes, that's where the term deep learning comes from. Okay, so here's a bit of the secret sauce that makes neural networks work: the activation function. This is a mathematical operation that determines whether a neuron should be activated or not, based on the input it receives. Think of it like a light switch. If the input is strong enough, the neuron lights up and sends a signal to the next layer. If not, it stays off. Activation function helps the network capture complex patterns in the data, allowing it to make accurate predictions. Let's put this into context with a real-world example. Imagine you have a neural network that's been trained to recognize handwritten notes, like the ones you might scribble on sticky notes. When you show it an image of a note, the network processes the image through its layers, with each neuron analyzing different features like the edges, loops, or slants of the letters. By the time the data reaches the output layer, the network has made a prediction, telling you what words or characters it thinks it's looking at. And these predictions can be incredibly accurate even when the handwriting is messy or written in different styles. Of course, neural networks aren't perfect. One of the challenges they face is something called overfitting. This happens when a network becomes too good at recognizing the specific patterns in its training data, but struggles with new unseen data. It's like memorizing the answers for a test, but not really understanding the material. To avoid this, data scientists use techniques like regularization and cross-validation to ensure that the network generalizes well to new data. On the flip side, there's also underfitting, where the network is too simple to capture the complexity of the data, leading to poor performance. So how do you train a neural network? It all starts with a process called backpropagation. This is where the network adjusts its internal parameters called weights based on the error it makes in its predictions. The goal is to minimize this error so the network gets better with each training iteration. But here's the thing. Training a neural network, especially a deep one, requires a lot of computational power. That's why you'll often hear about GPUs being used in AI. GPUs, or graphic processing units, are great at handling the parallel processing required to train these networks efficiently. So why are neural networks so important? Well, they are the backbone of many of the AI applications we use today. From voice assistants like Siri and Alexa, to recommendation systems on Netflix and YouTube, to advanced fields like natural language processing and self-driving cars. And the future, it's looking pretty bright. As we continue to improve the algorithms, hardware, and data that powers these networks, we're going to see even more impressive advancements in AI. But with all this potential, it's also crucial to think about the ethical implications and ensure that these technologies are developed responsibly. So to wrap things up, neural networks are inspired by the human brain and are a key part of what makes AI so powerful today. They work by processing data through interconnected layers of artificial neurons, learning from the data and making predictions. Whether it's recognizing images, understanding speech, or driving cars, neural networks are the heart of these technologies, and they are only getting better. But remember, with great power comes great responsibilities, and it's up to us to guide AI development in the right direction. I hope you guys found this video both informative and exciting. And if you did, make sure to give it a thumbs up and share it with anyone who might be curious about AI and neural networks. And if there is a specific AI topic you want me to dive deeper into, let me know in the comments below. As always, thanks for watching, and I'll see you in the next video.